Good morning, students, and welcome back to this recorded session. Today, in science classes, we are going to learn the properties of light. But, kids, we have to remember what is light? Well, kids, light is a type of energy. Yes, it's a type of energy that it could be waves, and also, so we have different types of them. Since the energy or since the light that we can see, that is called a spectrum, and the rest of them that we cannot see. For example, infrared or the ultraviolet. The light can be transformed into other forms of energy, for example, heat or electricity, and it travels in a straight line, en línea recta, and in all directions from the source of light. Y en todas las direcciones desde el recurso de la luz. For example, so imagine a candle, kids. Well, kids, we can see the light in a straight line, and the light it covers around the candle, kids. Okay, so what happened with that? The light travels very quickly. As I remind you, so the light travels very quickly at a speed of 300 million miles per second. We have different properties of light. We have the reflection and the refraction. Those two simple examples that we are going to see in this class. But what are they, kids? What are reflection and what are refraction? And what happens when we are using different type of lenses in cameras or by using our sunglasses or glasses? What happened with them? What happened with the light? What happened with all the things that are around us? Okay, let's start with the reflection. Well, kids, the reflection lets us see objects that do not emit light, no emiten luz. Okay, so when light reaches an opaque object, it hits the object and light changes its direction. The object reflects the light. That happens when you are looking at a mirror. Cuando se están viendo en el espejo, reflection happens. When we look in a mirror, we see our reflection in it because light rays do not separate when they reach the shiny side of the mirror. Imagine, kids, that you are looking at yourself by using your mirror, but you don't have light. So you cannot see anything. No pueden ver absolutamente nada because the light makes that the reflection would be possible. When a ray of light approaches a smooth polished surface and the light ray bounces back, it is called reflection of light. The incident light ray, which lands upon the surface, is said to be reflected off the surface. The ray that bounces back is called the reflected ray. If a perpendicular were to be drawn on a reflecting surface, it would be called normal. And here, you will see the angle of incidence and angle of reflection that are with respect to normal and the reflected surface. Now we have the refraction. The refraction is when a ray of light goes from air to water. Its speed changes. As a result, the ray changes its path. This is called, as I told you, refraction. When white light passes through a drop of rain, the ray of light refracts. Each ray of color separates, forming a rainbow. That is the refraction. Light also refracts when it passes through a lens, and there are two types of lenses, converging and diverging. The converging lenses make rays come together. The opposite of it is the diverging lenses that make that the rays separate. Refraction of light can be seen in many places in our everyday life. It makes objects under a water surface appear closer than they really are. It is what optical lenses are based on, allowing for instruments such as glasses, cameras, binoculars, microscopes, and the human eye. Refraction is also responsible for some natural optical phenomena, including rainbows, as I told you, and mirages. Light refracts whenever it travels at an angle into a substance with a different refractive index. That means the optical density. This change of direction is caused by a change in speed, as I told you before. For example, when light travels from air into water, it slows on, causing, causing it to continue to travel a different angle or direction. Okay, my dears, let's continue with the experiment. Well, kids, I have to say thank you and goodbye.